This is a view of the bridge in its as-cast state after we've finished casting in the casting yard. Each segment in this bridge has been cast with a small small casting error and a small sitting error, and we have put all the segments into our storage in our virtual casting yard, and we are now ready to build the bridge on the final construction site. Monitoring of the erection process of this bridge will be performed using ABES assemCon, and the data that we have available now from the casting yard shall be transferred to ABES assemCon in the following. Let's just quickly look at the as-cast state, and let's just exaggerate the casting errors a little bit so that we know that these segments are not perfect. And these imperfect shapes, exaggerated here of course, these imperfect shapes, they will be transferred into another program, assemCon, as we've mentioned, and assemCon will base all its predictions and all its previews and all its calculations on the actual physical as-cast geometry as we have created it in our casting yard. I have mentioned casting errors and I've mentioned setting errors in the past, and I'd like to dwell on these two types of errors just a little longer. Let's start with a setting error. A setting error is the difference between the physical location of a control point marker and the planned position of a control point marker. The two positions may differ, and that will not impact at all on the actual shape of a segment. It's important to keep track of the physical position, and it's important to keep track of the difference between the physical and the planned position, but these setting errors do not require any corrective actions on behalf of GeoCon or assemCon as it happens. A casting error, on the other hand, is an error that affects the shape of a segment and which requires compensation in subsequent segments within a casting sequence. ABES software keeps track of both errors, of the setting errors as well as the casting errors, and it corrects for the casting errors. So let's move on and transfer this data from our casting yard to a transfer file and send the transfer file off to the construction site. We use the file menu and we use export to ABES assemCon. We can now specify a file name, GeoCon to assemCon is a good name in this context, and we can store the data into this file. So let us assume this transfer file has been sent to the construction site where the crew has received the file and already launched or started ABES assemCon. This is the user interface of ABES assemCon for a empty, naked project. We can use the file menu and start a new assemCon project, and we will take our inputs from a GeoCon export file. This is the export file that has been generated, or that we've just generated and has been sent to the construction site. Say we can make some naming conventions or change some naming conventions here. We won't do that, and press OK. If we have more than one license, we choose one and we save the project into a file name. We have now transferred successfully our as-cast geometry from ABES GeoCon into ABES assemCon, and we are ready to monitor the construction of this bridge and compare the survey data with our stored data and make corrective actions or if we need to. We will go through the motions of how to use ABES assemCon in subsequent video clips. For the time being, I would like to conclude this video by giving a brief introduction of the assemCon user interface. In many ways it works similar to ABES GeoCon. We have the next button here, and every time we want to simulate the next action on the construction site, we click on next. We will do that. It's similar to ABES GeoCon. We also have a visualization region here for the visualization of our bridge or the many states of the geometry of our bridge. We have a list of all the segments down here, and we have a number of options over here which are at the core of assemCon and which we will be using a lot in the coming video clips.